Hey everybody, this is Mr. Beckstrom, and today I want to go over this challenge problem that I gave you. And remember, it was what distance is longer? Is it the distance around the square, basically the perimeter around the square, or the distance around the circle, which is that circumference around the circle? And I didn't give any lengths. I just said that it's the circle that intersects at the midpoint of one of the sides of the square and the opposite two corners, like so. So let's see if we can go ahead and get a solution to this problem here. And using some of the trigonometry that we've learned so far. So I'm sure there are many solutions to this, but here's how I would go about doing it. So I'm going to go ahead and locate the center of this circle here, like so. And let's go ahead and define what the perimeter of the square looks like. So the perimeter is going to be equal to, what is that? 4 times the length of a side. So that's going to be 4 times the length of a side. And the circumference of the circle is equal to 2 times pi times the radius. 2 times pi times the radius. So my goal here is either to get the side in terms of radius or the radius in terms of its side, and so that way I can compare to see if I can get one of the values larger than the other. So that's kind of my idea here. So I'm going to start to try to make triangles and see if I can make some kind of relationship here to get this going. So let's go ahead and first draw a line down here. And this is going to end up being the radius, right? So we'll just call that R of the circle if this is the center of the circle. So we can draw a radius here, and let's do another radius there. So we've got a radius here. And then I can draw a line straight down to the bottom here. This line from here down to the bottom, that's not a radius, and it's not the length of a side, so we don't really know what that is. Let's just call it x for right now. And then we do have a right triangle though, because we drew it straight down, making a right angle. So we have half of a side here. So we could either call that 1/2 s, or we could call it something else. Let's go ahead and call it y for now. So we'll call that y, and then we'll also call this y here as well. So now we do have a right triangle, and we also have our r. So this does form a relationship between kind of the side of a square and the radius of a circle. And that relationship can be brought together through the Pythagorean theorem. So let's go ahead and do that. So we know x squared plus y squared is equal to r squared, right? So this squared plus this squared is equal to that squared. All right, now what do we know? All right, just give me a second here. Well, we know that x plus r is the length of a side, and y plus y is the length of a side. So we know that x plus r is equal to 2y. So let's go ahead and use this information here in our Pythagorean theorem, and that should allow us to get rid of one of these variables there. It should allow us to get rid of the x's. So if I solve for x, I get x is equal to 2y minus r. Just trying to do some substitution to get rid of my x's. So this is going to end up being 2y minus r squared. I'm just substituting in this x into here, plus y squared is equal to r squared. And then I can just FOIL that out. So that's going to give me 4y squared, and this is going to be 2yr or negative 2yr minus 2yr, so that's minus 4yr plus r squared plus y squared is equal to r squared. And then 4y squared plus y squared is 5y squared. 5y squared. I can subtract an r squared from both sides. And then finally, I'm going to move this. Did I forget an r here? I think I did. Yeah, that should be 4y. Yeah, I think I put that one in wrong. That should be 4yr, excuse me. 4yr. And then I can just move that 4yr to the other side is equal to 4yr. And because we know that y has to be greater than 0, because we're only dealing with positive lengths, we can divide both sides by y. And so we're going to end up getting 5y is equal to 4r. And that's going to let us do a nice substitution. So coming back up here, remember the length of one of these sides is s, and it's also 2y. So let's go ahead and do that substitution here. So the perimeter is equal to 4s, but s is equal to 2y, so that's really going to be 8y, right? As you can just put the 2y in there for s, so 8y, and then the circumference of the circle is equal to 2r pi. I'm going to put it in like this, and now we have a substitution over here, and let's go ahead and we can really do it either way. I'm going to go ahead and solve for r. So if I solve for r, I'm going to get r is equal to, divide both sides by 4. So I'm going to get 5 over 4y. And then I can come back over here and do that substitution. So that's going to be equal to 2 times 5 over 4y, 5 over 4y times pi. And that's going to be equal to 10 over 4 times pi times y. All right. So we're pretty much done with this. So now we know the perimeter is going to be equal to 8y. This is the perimeter of our square is going to be equal to 8 times y, right? Because the y is half of one of these sides. And we know that the circumference is going to be equal to 10/4 times pi times y, right? And y is half of one of these sides, right? So the larger or the longer of these two distances, it's going to be whichever value is higher, 8 or 10/4 times pi. So all you got to do is put this in a calculator. Let me go to my calculator and do, you can already see I did that, 10/4 times pi. So 10/4, let me parentheses, 10/4 times pi. Second pi. And you get a value that's just under 8. So this is 8 times whatever you put in for y. This is just under 8 times whatever you put in for y. And that tells us that the perimeter of the square is going to be longer than the circumference of the circle. So I hope that was at least a little bit interesting. If you have any questions, let me know, and hope you have a great rest of your week. Thanks.